Okay. So welcome everyone. Good evening. How are you? So I welcome you all in the session of wave on a string, which is wave mechanics especially. This is lecture number 5. We have discussed lecture 4 on this topic. Okay. Now in the previous lecture, what we have did, we have seen the speed of transverse wave, speed of transverse wave in solid medium, in a string, stress string, and in a material, solid material. Then we have seen the speed of longitudinal wave and the speed formula given by Newton that we have also seen in the longitudinal wave, or especially in air. And then we have seen the Laplace correction of the same. Okay. So we will first revise what we have did. Just a second. Yeah. So speed of transverse wave on a stress string, that is the formula here. V is equals to square root of t by mu. Now where t is nothing but the elastic factor, I have told you, or elastic property you can say. And mu here is nothing but the what? Mu is inertia property or inertia factor. This is somehow in the weekend class, if you remember, we have did a formula of time period. And what is that formula? It is 2 pi square root of what? Inertia factor divided by the spring factor. And spring factor you can relate with the elastic factor. Now we know the formula that V is equals to F lambda. V is equals to F, you can write 1 by T. So if you put the T here, the value of T, so V is directly proportional to what? Elastic factor and the inertia factor. So it is also verifying our statement that this velocity will depends on the elastic factor of the material and the inertial properties. Okay. And how it is depending, we have discussed. Okay. And why it is depending on these properties, that's what we have discussed also. Right? Remember, Divyanshev gives the answer that it is directly proportional to elastic property and inversely proportional to the inertia property. Why it is so? Because if inertia increases, the mass increases, so it is hard to move or hard to vibrate that particular material. Same thing with the elastic property. More is the elastic material, more high will be the vibration. So more high will be the speed of wave. Okay, so that is why the elastic property is a directly dependent factor, and inertia property is the inversely dependent factor. Okay. Now speed of a longitudinal wave that we have also discussed, it is B upon P. Because in longitudinal wave, especially we are focusing on the change of pressure for a particular volume. Because we know that longitudinal wave may the particle will move along the line of wave motion. So it is just compressing or decompressing, you can say. So due to compression, there will be an increase in pressure. Due to decompression, there will be a decrease in pressure. So for a particular volume, the pressure will increase, which means the material or the medium is compressed. And for the same value, when we decompress it, the volume will increase and the pressure will decrease. So that is why here the same thing, if we follow the elastic factor, it depends on the bulk modulus of the medium, that how much it can compress and how much it can decompress. Okay, so that will totally depends on the bulk modulus of that medium. That is why bulk modulus here is the elastic property of that particular medium in which the wave is traveling. So here point is to note that that this velocity is directly dependent on the medium properties. Okay, because these wave, longitudinal wave, will depends on the medium. Okay, it's a factor of medium only. Now, and this rho here is the density of the air or density of the medium, and specifically we are focusing on the gases, so rho is the density of gas here. Now a sound speed of a sound wave, you can say, in gases. So it is given by Newton formula. What Newton has considered here? Anyone remember? Do you know what Newton has said? Anyone? Tell me how we reach this formula. How had we reached this formula? So by, because Newton says that just a second. Yeah, very good, Divyansh. So he told us that the movement or the propagation of wave, the propagation of sound in a medium or specifically in air is a isothermal process. So what does it say? That if this is the particular medium the gas is using or the sound is using in propagating wave, this is gas specifically, and the sound wave is traveling in this way. Okay, now, so what has happened when we compress it? There will be a increase in pressure, and we know that pressure is directly proportional to temperature. So we can say that if we compress it, there will be an increase in pressure, so increase in temperature. So that temperature will be shared by surrounding. This increase in temperature, let's say at this zone there will be a compression, so this temperature will increase and it will be shared with the surrounding. Now when it decompress, so in decompress, it takes the temperature from the surrounding because the pressure decrease, so temperature will decrease. So to maintain the temperature, it takes the temperature that we have previously give to the surrounding. So temperature remain constant in this process. Whatever we give to the surrounding, we will take it in the decompression. So he suggested that this process is isothermal process because temperature is not changing in this process. And based on that, he come up with a formula that V is equals to root of pressure upon density. Okay. But after 100 year of its calculation, we are not getting the result, and approximately I think 15%, 15 to 16% of deviation has been shown from the original result. Okay. Let's say the speed of sound is given by 332 meter per second at NTP. NTP means natural temperature and pressure. But if you put the values of natural temperature and pressure in this formula, the velocity that you are getting with Newton is approximately 280 meter per second. So there will be a difference. Percentage difference will be 15%. Okay. So that is something that we can ignore. Although Newton has a big name, but this much amount of deviation we can't ignore. We can't tolerate. Okay. After that, Laplace came into the action, and he said that this process that Newton has assumed isothermal is actually adiabatic, because the movement or the propagation of wave or sound wave in a gas is a very fast process. So if this process is happening very fast, very rapidly, there will be no time, there will not be a sufficient time to change the heat. And by changing the heat means to share the temperatures, to change the temperatures. Okay. So there will be not a sufficient time that it can take the heat from surrounding or give the heat to surrounding. Okay. Although itself, it can change its temperature. If you consider this particular volume to be system, the temperature of the system will change. But it has no time to equalize this temperature with the surrounding to form a thermal equilibrium that Newton has said. Because this process is very rapid. So that is why he has said that there is no exchange of heat between the system and surrounding. So we know that a process is exist, such a process is exist, and that process is adiabatic process. So you can note down that this is from the isothermal process, which is the wrong one, and Laplace has given the correct one, which is adiabatic process. Okay, got it. So that is why this extra factor, just gamma, has to be added in this expression, and we get the approximate value of sound, propagation of sound, which is comes nearly 331.6 meter per second, approximately. Okay, at NTP, natural temperature and pressure. Got it? This gamma here is the adiabatic index, okay, which depends on the what type of gas we have take, what is the atomicity of the gas, it is monoatomic, diatomic, triatomic, and that I have discussed with how to find the gamma. Okay, and try to remember the at least three values of gamma for monoatomic, diatomic, and triatomic. Okay, now this is it. I think you don't have any issue in this. If you have, you can ask in the chat box. So we will move further now. The effect of changes in pressure on speed of sound. Now here, very interesting formula we have find out, and very interesting concept it is. We know that velocity or the speed of sound specifically depends on square root of p n rho. Now some of you, and even me also, when I was at your age, I can also say that velocity or the speed here is directly proportional to the pressure, because it is the v is square root of p upon rho. So we can say that v here is directly proportional to square root of p, but this is not the fact here. Okay, although it seems, try to note it down, it seems that speed here, speed is dependent on pressure in this expression. Okay, now, but now pay attention to this concept, each and every one. Now we can write that PV is equals to mu RT or nRT. N is the number of mole. Okay, now P is equals to N. I can write what? Small m upon capital M into V into R into T. Now this small m upon capital V is the density of the gas. So we can say that P upon rho, because it will become rho. So P upon rho is RT upon capital M. Now this pressure upon density, This particular fraction will depends on temperature only. If we will see, for a particular gas, the M will be fixed. R is universal gas constant. So this pressure by density itself completely depends only on the temperature, which means if you keep the temperature constant and change the pressure of the gas, there will be no effect in the velocity. And why it is so? Because if you increase the pressure, there will be a sufficient increase in the density also. Let's say, for example, in a cylinder piston arrangement, we have this piston here, okay, and this is the particular volume that it occupies right now. Now, if we compress it, this particular gas which is filled inside it has a particular density rho and volume here is V. Now, if we compress it, then what will happen? It will come to a new position here, and there is the only remaining volume is this. Has a mass decrease? No, because mass is conserved. Only the mass particles or the atoms come nearby, come very close to each other. So there will be a sufficient decrease in the volume. Now we know that rho here is mass upon volume. So if volume is decreased, which means that rho, which is density, is also decreased. Got it? Have you got this? Okay. So this P upon rho, this P upon rho will itself manage so that it only depends on the temperature. So if you keep the temperature constant, this P upon rho is already constant, because they will also depends on each other, that pressure increase, density decrease, density increases, pressure decreases. Sorry, if the volume is decrease here, the density will increase. Sorry for the misconcept here. So density will increase. So if pressure is increasing, density is also increasing, which means P upon rho remain constant. Got it? When the temperature is constant. But if you change the temperature here, this complete value of P upon rho will change. So we can say that this fraction itself depends completely on temperature. We can say that, note it down. Here, pressure upon rho combinedly depends on temperature. And one reason you can here give that increase in P, increase in rho at constant temperature. So P upon rho equals to unchanged. Got it? If you have any kind of doubt in this, you can ask right now. Okay. Otherwise, give me a thumbs up so that we will move further. Very good. Very good, Divyansh, Hema Sundar. What about student of JNV Ramnagar? Yoga, Stephen, thank you. So we can say that V is equals to, okay, got it. V is equals to RT upon M. Okay. Now, you can also say that V1 upon V2 equals to square root of T1 upon T2. If T in degree Celsius, so you can convert it into Kelvin. So you can say that V1 upon V2. Obviously, if let me discuss it in the next slide. Okay. Now, effect of change in temperature on the speed of sound. So we know that on speed of sound, it will depend directly because V is square root of rho upon, sorry, P upon rho. Let me change the color. Is this visible to you? I think it is visible to you. So P upon rho is nothing but RT upon capital M. So we can say that V here is directly proportional to square root of temperature. So that we can conclude that V1 upon V2 equals to square root of T1 by T2. Now, let's say at STP, temperature here is 273 Kelvin. Okay. And at 0 degree Celsius, I'm saying at T is equals to 273 Kelvin, the speed of sound is 332 meter per second. What is the speed of sound at T degrees Celsius? So we can say that V1, let's say V1 is the speed at that particular temperature. V2 we have here, or you can say, yeah. Initially the V1 is the speed, so it is 332 divided by V2 equals to square root of 332 speed we have at 273 Kelvin. Now V2 we have at T2 degree Celsius and T2 here is given small t. So we can write it as T plus 273. If you invert this, it will become V2 upon 332 equals to square root of 1 plus T upon 273. Okay. Now what you can do, you can take the square root of it and then calculate the final. This you can also keep in your mind, this expression. Okay. If the temperature is given in degree Celsius, so use this expression. Otherwise, you can directly write it on. Okay. This you can also do. Now, move on to the next one. This is very important and very logical also. So please try to pay your full attention to this topic. Effect of change in humidity. What is humidity? Anyone can guess? Anyone have any idea about the humidity? We often see this term, humidity, humid, humid air. There is lots of humidity today. We can say it. And we will be saying in the upcoming days because there will be a humidity in the air. So what does that mean actually? Anyone? Any idea? Vapor in air. So Divyansh is saying that humidity means vapor in air. Yeah, absolutely correct. but this vapor should belong to water vapor, okay, or the liquid vapor, you can say. So the amount of vapor, or I think the amount of water vapor in air is termed as the humidity of that air. More is the humidity means more is the amount of water. Got it? So this gives you an idea that what we are going to talk about. Now we know that the velocity of sound is nothing but pressure upon density. Got it? Now what you will see, humidity means, let's say this particular section we are talking about. Initially, there are two situations, initial and final. First, we see the initial case. So let's say we have only air molecules. There is no humidity in air. So we are specifying only the air molecule here. Got it? And this particular volume is volume V. This is the volume. And now what will happen when the humidity is come? So there will be a molecule of H2O also within the same region. These bigger balls are the atoms of hydrogen. Now what will happen? This you can write also RT upon M. Now, when this sound is traveling in this non-humid air, there will be nothing change. This is air molecule only here. So the speed will be unaffected. But when these water molecules comes across the sound wave, then what will happen? If you see, the volume is same. We have the same volume. But effectively, if you see, let me see the number of air atoms. So can you see the effective number of air atom has been decreased in this, because most of the volume, H2 is a bigger molecule than air molecule. So most of the volume is occupied by the H2O molecule. But the propagation of this wave will only depends on the air, because we are talking about the air. So if you see the effective number in humid air, effective number of molecules of air in the same volume, will what? Is it increasing or decreasing? Tell me. Is it increasing or decreasing after adding the humidity? What will be the effect on the effective number of air molecules? So very good, Divyansh. You are saying that it has been decreased. Now, this density depends only on the mass of the air divided by volume of the air. Now, volume is not changed, but can we say the mass is not only changed? Mass is not also changed? No, we can say. because the effective number of atoms has been decreased in that particular volume. So we can say there will be a decrement in the average value of this molecular mass. This is molecular mass. So molecular mass, effective molecular mass of the gas will decrease, because here if you talk about density is nothing but mass upon volume. Here is also rho dash is mass upon volume, m dash upon volume. Now m dash is somehow less than the previous one and v dash is same. So what will happen? Density will decrease. Clear? Because the number of atoms of air effectively will decrease, because most of the air atom will be replaced by the H2O atom in the same volume. I am not saying that the number of air atom has been disappeared. No, but we have added extra atoms of H2O, so they have been, the volume has been much bigger than. But if we are strict to that confined volume that we have taken in the previous case, in this one, so if you see the number of atoms are reduced, it doesn't mean that they are disappear. Mass is constant. They have moved further. They have moved further, but they have not collapsed, or they have not, let's say, okay. So the effective number in this particular volume is decreased or reduced. Got it? It is the same thing. If you have a tub, got it? And you are initially it is filled with water in the time of Holi. Initially it was filled with water. Now what you have done, you have taken so much of balloon filled with colors, or you can say they are filled with water itself, the other color water. So this is the water itself, pure water. Now you added balloons to this water. Can you say the effective number or effective mass of the water is same? Can you say in this particular volume, let's say here the height is 2 meter, 2 centimeter. Here we have kept this 2 centimeter. The base area is same. So can you say the same mass is there in this case? In this case, let's say water is 2 kg. So can you say that still there is a 2 kg of water if you do not consider the water inside the balloon? Anyone? Any guesses? Will it remain same or decreased? Divyansh, JNV Ramnagar student, Sumad, Stephen, Yoga. Yeah, very good, Divyansh. It will decrease. Okay. And next time I will want the answer from each and everyone. Okay. So this there will be a decrement, and in the same way you can relate it. We have added the water balloon. You can say it that we have added the water balloons attached with these air molecules. So the effective number of air molecule has been decreased. So if the number of molecule is decreased, number of the mass is also decreased, average mass. And if the mass is decreased, the molecular mass, the density will also decrease, because it depends on mass upon volume. If mass is decreasing, volume is constant, then density will decrease. So in humid area, effective number of molecules of air in the same volume is less than the, just a second, number of molecule of air in no molecules of non-humid air. So density decreases. Hence, we can say that speed decrease, sorry, increase. Because if rho decrease, the whole expression will increase because the pressure is constant outside. Speed of sound wave increases with the decrease of or with the increase of humidity. Got it? Now I think it's clear to you. Anyone, any kind of doubt? Okay. So now this is the question. So a wave is described by y is equals to 2.00 centimeter sine kx minus omega t, where k is itna 2.11 radian per meter and omega is 3.62 radian per second. X is in meter, t is in second. Then determine the amplitude, wavelength, frequency, and speed of wave. Okay. Now try to solve it. I think these answers, the amplitude, frequency, can be directly obtained. Okay. Because we know the general equation of sound is A sine sound wave is omega t, or you can say the kx minus omega t, that we have obtained also. So if you compare with this equation, you will get directly the value of A, which is amplitude and which is given to you 2.00 centimeter. So amplitude is given to you. You can directly say that amplitude is 2.00 centimeter. Now, if you talk about the wavelength, so you can compare with this K. K is nothing but 2 pi by lambda. I have seen it. This is the wave number. Now, lambda will be 2 pi upon K, 2 pi upon 2.11. So if you further solve it, you will get the wavelength, which is in meter. Simple. If you talk about the frequency, so you can relate it with omega. Omega t, omega is also given to you 3.62. Nothing to do with the extra effort is not required here. So omega is nothing but 2 pi f. So f is omega upon 2 pi. Omega is 3.62 into 2 into pi hertz. Okay. So this is the frequency. This is how you're going to find out frequency. Now the speed of wave. So we know the formula. The speed of wave is given by omega upon k magnitude. Omega is given to you 3.62. K is given to you 2.11. So if you solve it, you will get the speed of wave in this. So this is the speed of wave. Look how simple this numerical is. Okay. Got it? Anyone, any kind of doubt in this? And if I ask you that in which direction the wave is moving, then who will going to answer? If anyone gives the answer, you definitely deserve a trophy. Okay. And whenever I visit to your school, I will definitely give you that trophy. Okay. But you need to tell me that in which direction the wave is going. Either it is positive x or negative x, positive y, negative y, where it is going. Anyone? Divyansh is saying positive x. Why? Why not negative? Only Divyansh is saying. Now you are saying negative. Okay. So yoga is saying negative x. Okay. Got it. Got it. So what about the Suma and Sashirekha, JNV Ramnagar student, Bharat DS? What about you guys? What did you say? What do you say about that where the wave is going? Either in positive x or negative x? Suma is saying in negative x. So actually the fact is the NV Ramnagar is saying negative x. Okay, so you have not studied your notes properly, okay? Because I have told you that in wave function is ax plus bt plus minus bt. So if the ax and bt has same sign, then in this case, wave is moving in negative x direction. And if they have opposite sign, the wave will move in positive x direction. Okay. So in this case, if you will see, the kx and omega t have opposite sign. Kx is positive, omega t is negative. So we can say that wave is moving in positive x direction. Got it, everyone? Any confusion now? Okay. So you also get it, na, JNV Ramnagar student? Okay. Now, so this is all we have solved it. The final values you can also. Yeah, Divyansh, you already have told the right answer. Now this question you need to solve. That figure shows a string of linear mass density 1.0 gram per centimeter on which a wave pulse is traveling. Find the time taken by the pulse in traveling through a distance of 50 centimeter on the string. Got it? And generally what I have studied it, that this wave pulse which is formed in the string, which is attached to some point, is we consider as circular pulse. Okay. I will discuss the questions related to this in the weekend class. So to please be attentive in this in that case. Okay. Now try to solve it. First of all, how to tackle a question, what should be the approach? The approach should be very clear. That firstly, write the things which is given to you, and whichever the concept comes in your mind first, try to do with the same. Okay. Try to lead the path with that concept. Okay. So here the key points is, keyword is string. This is a string. The mass is hanging, which means a string is stressed condition. Oh, there will be a spark in your mind, na? that we have seen the speed in a stress string, and there is a formula there. And what is that formula? That formula is V is equals to square root of tension upon mu. And mu is already given to you, linear mass density. There is no point of like discussion here. Tension will be same, which is given by the, this string is stretched by this 1 kg block. So tension will be, T will be mg. Mg is nothing but 10 Newton. G is 10, M is 1. So if you put this value, this will be 10. This is 1.0 gram per centimeter. So you need to convert it into kilogram per centimeter. Kilogram per meter. So mu is 1.0 gram per centimeter. So in 1 gram, we have 10 raised to the power minus 3 kilogram divided by, in centimeter, we have 100, 10 raised to the power minus 2 meter. This will be kilogram. Now this 10 raised to the power minus 2 will jump in the upside. It will become 10 raised to the power minus 1 kilogram per meter, which is nothing but 1 by 10, you can say. If you put the value 1 by 10, this will become 100. Square root of 100 is 10. 10 meter per second is the speed of the wave. Now, how much distance it has traveled? It has to travel 50 centimeter. 50 centimeter is nothing but half meter. Okay. So distance you have to travel 1 by 2 meter. Speed is given to you 10 meter per second. So what you can apply, that T is S upon V. Got it? S is 1 by 2. V is 10. So it will become 1 by 20. 1 by 20, which means 0.05 second. So how many of you given 0.05? Let me see. Okay, so JNV Ramnagar student has found it well. Very good. Keep it up. Hema Sundar has also did it. What about Divyans? Divyansh, have you not tried this question? Okay, so time period, you got the same answer, na? 0.05 second. Got it. Okay, so this is it for today, guys. In the next session, we will see the pressure wave, sound wave as a pressure wave, and density wave also. We will also discuss the intensity variation, how to find the intensity, the power transmitted in the string, wave in the string. Okay, power transmission, intensity, and yeah, some numerical, maybe one or two. And we also see the reflection of sound by the solid surface and flexible surfaces. Okay, free surface, you can say. So try to read these topics with the help of NCRT and whatever the module you have got. Try to read this, go through these topics, and then we will be attending the session in the tomorrow's class. So there will be very beneficial for you if you take a look on that, on these topics. Got it? No. If anyone has any kind of doubt, they can ask. Otherwise, the lecture is being over. Thank you so much for being attentive. Bye bye. Take care of yourself. Thank you.